So if you're in my class, you've already done this drawing. You've labeled absolute minimums, relative maximums. Technically, there is no maximum. This graph is going up to tons of infinity. But there is a minimum because that's as low as it possibly gets. That's the absolute lowest point. Now, how do you find those? Here's how we're going to do it. We're going to show you how to find them. So listen, right now, what I want you guys to do, which one do you think is the easiest one to locate out of?
The relative.
Yeah, so the relative maximum, what's the ordered pair for the relative? 0, 0. So we know that's the ordered pair that goes with that. But how do we find the exact absolute minimum? This is where you guys need to follow along. I'm going to show you how to do it in the graphing calculator. So here we go. Hit second. Trace. What number do you think I'm going to do? Minimum. Second trace, minimum. Now watch what happens. It says what? Left bound. If I want to find this guy, I have to move the cursor past it. So move the cursor past it. Would you agree now this cursor is now past my absolute minimum? Press enter. Then what's it asking you to find? The right boundary. You see how I made the left boundary line in those nice calculators that you guys have? Thank you, Mr. Lappick. Everybody say thank you, Mr. Lappick. Okay, that's right. Thank you, Mr. Lappick. That's how I was. Now, right here, you see how I moved it past it? Press, once you go to the right bound, press enter. Now, the calculator is going to calculate the minimum between those two boundaries. Press enter one more time. And by the way, this right here is the absolute minimum. At what? At negative 1.22, comma, negative 2.25. That's the absolute minimum.
That'll be the same on the other side, but
yes, I want it to be that specific tomorrow, knowing that I just gave you instructions on how to do it. Well, I say tomorrow, I mean Friday. So, how would I do that again? Let's try that one more time. Ready? Second, trace, number 3. Unfortunately, this time, everybody, I have to move way over here. So my left boundary, I don't have to get super, super close to the minimum. That's good enough. I'm going to press enter. See how it creates that vertical boundary right there? Now I'm going to do my right side, go past the minimum. Let me know when you think I've passed the minimum. Yeah, I passed it. Good. Otherwise, I'm going to go off the screen. So notice, what does the calculator do? It's going to calculate the minimum between those two boundaries. So just press enter one more time. And there it is. So what's my absolute minimum over here? 1.22, comma, negative 2.25. Now what does that prove to us? That proves to us actually that this right here actually is the absolute minimum, because what does that do with the other one? It matches it, doesn't it? Hold on. One of them is just a negative, one of them is a positive as far as the x values. Okay? What type of symmetry does this have? What type of symmetry? Across the what? Across the y-axis. Okay, it has line symmetry. If you're wondering what is line symmetry, this is an example of line symmetry. I'm telling you this because we're almost done with the class, and anytime a graph has line symmetry, that lets you know that this is an even function. I know I didn't ask you about this, but all even functions have symmetry across the y-axis. All odd functions have symmetry with respect to the origin. You need to know the difference between those. So that's how you guys find the absolute minimums using the graphing calculator.
what was the word?
Find the slant asymptote for number 15. So by the way, the answer to number 15 is going to be in the form of y equals mx plus b. And we know we're going to have the slant asymptote because, first of all, it says find the slant asymptote. And second of all, because you know that this degree is 1 degree higher than that x, which is technically x to the first. All right? Now we need to review how to do some synthetic division. So here's how you do synthetic division one more time. First of all, you labeled how many x squared you have, how many x to the first, how many x to the zeros. How many x squared do we have? 2. How many x to the first? Negative 5. How many x to the zeros? 2. And by the way, if this is x minus 3, then you have to divide everything by 3, because it's x minus, it's always the opposite. Alright? This is the factor. This is the root.
Bring down your 2.
Bring down my 2. What am I going to do next?
5.
No. No. What am I going to do? 3 times 2. Thank you. I don't want the answer. I want the process. The answer is meaningless. The process is everything.
3 times 2.
So 3 times 2 gets you to 6. Now we are going to add these together and get a a positive one, because 6 plus a negative 5 is 1.
That'll be 3. That'll be 5.
3 times 1 is 3. Add it together. Okay, now listen, I'm going to circle this.
You ignore the remainder.
Ignore the remainder. That's how I felt last period. Last period, I felt like a remainder on finding a slant asymptote. Okay? Yes. Totally ignored. So you know what? When I'm grading their papers, I'm going to be grading them exactly as they should be. No half points for getting them partially right. So listen, right now we have a 2 and a 1. What the heck does that mean? That's how many x to the firsts. That's how many x to the zeros. My slant asymptote is y equals 2x plus 1. So right here, for number 15, you would write y equals 2x plus 1 in the answer box, and that's how you're going to find your slant asymptote tomorrow or Friday, depending on when you have me. Hope you have a fabulous day. It is almost time for your next class.